Hello guys, welcome to Inspire Educare. I am Aditya. In this video, we will solve one problem from the topic linked list, which is generally asked in interview. Today's question is to find the intersection point of two linked lists. So in this question, we are given a two linked list and we have to find the node at which the intersection of two singly linked lists begin. So basically, let's understand it with the help of an example. So here we have a two linked list A and B. So the linked list A is A1, A2, C1, C2, C3, and linked list B is B1, B2, B3, C1, C2, C3. So the output come out as C1 because this is the point where both the linked lists are intersected. So this is the intersection point of two linked lists. So we have to return that node. So let's find out how we can solve this question. So the first basic approach is by using two loops. Using two nested loops, the outer loop will be for each node of the first list and inner loop will be for the second list. In the inner loop, check if any of the node of the second list is same as the current node of the first linked list. If this is the case, return that node. So basically we will have two loops and we will check for first for A1. We will traverse this linked list and check if any of the node is equal to A1. Then we will increase it to A2. Then we will traverse the whole linked list again. Then we will do for C1. Then while traversing we will find that this is also in the second list. So we will return this C1. So by this approach, the time complexity will be O of n cross m. So n is the length of first linked list, m is the length of second linked list. So this is not a better time complexity. So let's understand the second approach. In the second approach, we will take help of the length of the linked list. So we will traverse the first linked list and store its length. Then we will traverse the second linked list and store its length. So here the length of A is 5 and length of B is 6. So whosoever length is more, we will start traversing it first. So we will traverse the linked list B till 6 minus 5, that is equal to 1 times. So let it be big and let it be small. So we will increase our big by 1 time. So here big will come at this point. Here n equal to 5 and m equal to 6. So 6 minus 5 is equal to 1. So we will increase our big by 1. Now we will increase our big and small pointers simultaneously. So after this, big will point here and small will point here, and we will check if both the nodes are equal or not. If they are not equal, we will again increase both the pointers. So here comes big and here comes small. Now this is the point where big is equal to small. So here big is equal to small. So we will return this big from here. So this node will be returned. So this is the case. So this is the approach to solve this question. Now let's see the code for this. So here in this function get intersection node, we have passed two linked list A and B. So the first case is if A is equal to null or B is equal to null. That means if any of the linked list is null, then we have to return null because there is no intersection point. So now we have made two pointer, temp1 which will point to A, temp2 which will point to B, and we have declared two variables length1 and length2 to count the length of the linked list. So here we have count the length of the first linked list, that is till temp is not equal to null. We will increase our temp to temp next, and we will increase our length len1 by 1. len1 plus plus. So in this we have calculated the uh, length of the second list. So now we have initialized two list node variable big and small, and there is a int variable len to keep the difference of the two length. So if len1 is greater than len2, that means a is greater than b. So we will initialize big with a and small with b, and we will take the len as len1 minus len2. That is the difference between the length of the two nodes. Otherwise, if this condition become false, then big will be b, small will be a, and len will remain same. So now we have to increase our big pointer till len times. So we have run a loop while len minus minus, and we have increased our big pointer to big next. So now we have initialized and we have taken a variable flag and initialized it with 0. So we have run a loop till big is not equal to null and small is not equal to null, and have checked the condition. If big is equal to small, that means both the nodes are same. So we will make our flag equal to 1 and we will break from here. Otherwise, we will increase our big and small pointer by 1 simultaneously. That means big equal to big connects, small equal to small connects. So if flag is equal to 1, that means we got the intersection point. So we will return big. Otherwise, if the flag remains 0, that means there is no intersection point between the two linked lists. So we will return null in that case. So this is the code for this. So let's submit it and check if it is correct. So this code is correct. Thank you all for this. I will see you in next lecture. Till then, keep learning and keep exploring.